Hello everyone, this is Vikas. Welcome to Edumoon's Doubt Clearing session. In today's session, you'll be clearing all the topics related to microprocessors and every question and everything. So, for this, without any waiting further, let's welcome Samuel sir. So, welcome Samuel sir.
Yeah,
Hello sir.
because am I audible to you?
Yes sir, you are
Yeah,
audible.
hi. Okay, right. So possibly can you share the screen with the syllabus copy? And if there are any
Yes
doubts,
sir. Okay, so
I
first
guess
I'm
I can
sharing
see the.
the syllabus sir. Yeah. Okay. Yes sir. Yeah.
Okay, right. This is the syllabus copy for the microprocessor subject for the Andhra University second semester students. I think the exam will be starting tomorrow. Tomorrow morning, and also we had an exam. You can never late to clear your doubts. So here we have seven chapters. The subject is divided into seven chapters, and mostly students feel this subject is very vast syllabus basically. So mostly students have a doubt how much to study actually, because each of the chapter have different textbooks again. So this entire syllabus compromises of almost three different textbooks, and there is a vast topics covered in each of the textbooks. So it is really difficult to find what is the right thing to write for the given question. So I'll just give you an overview of the chapters to what to just go with. For example, the first chapter is about 8085 microprocessor. The second chapter is about 8086, and you can see there the only for 8085 microprocessor there is a prescribed textbook called as Ramesh Goenka. So in that we had only a small part of that. That's why the syllabus is given us only a brief architecture and programming of 8085. So there are many interfacing and other concepts which are not given in the syllabus. So brief architecture and the programming of 8085. So definitely you can expect a question about the architecture diagram, the spin diagram, what are the different registers, and what are the necessary things for programming. So whenever we say that programming, obviously we need to go with the instruction set, the flag registers, and the addressing modes. The addressing modes is a very important concept. So, and after just going with the first chapter, we'll have the same similar concepts for the second chapter, that is 8086 microprocessor. So, which is an advanced than the 8085. So, where the 8085 is 8-bit microprocessor and 8086 is a 16-bit microprocessor. So, if you are thorough with the first chapter, then you can easily understand what is the difference between the first and the second topics. So, like for example, in the first chapter, you study the architecture diagram, flags, and addressing modes. These are the three things I mentioned. So the same topics also repeated for the second chapter. We'll also go with the architecture of 8086, the addressing modes of 8086, and the flag list of 8086. And coming to programming part, so we need to have the glance of the instruction set first of all, at least the categories, because there are a huge number of instructions, nearly 240 odd instructions are there for 8085. So basically, you can go with the category wise, like what are the instructions in data transfer, what is the instructions about the arithmetic and logic operations, branching. So mostly in these two topics and the last one, they might ask you a program. Right? The basic progress, what you might have done in the earlier lab sessions, like addition, subtraction, multiplication, division. So these are very basic programs: addition, subtraction, multiplication, and division. So if at all there is a very uh, complex program, that will be like largest or smallest of given numbers, and ascending and descending of the numbers. So these are the programs, the basic six programs you need to go with. I think we have the notes that is shared. So I think because you can share the notes on the screen.
Oh yes sir, I'm sharing to right now. Yes sir, all is there. The access is given to you. Yes sir, you can see.
Uh, okay, this is the microprocessor, which is I think provided for all the classes mostly, or else you can download from the original. So here you can see the starting chapter. It's the unit one. We start with the introduction to the microprocessor controller. We discuss very basic things. What is a microprocessor, etc. Here, and then we go with this architecture diagram. So this is the architecture diagram we were mentioning earlier. So this is the architecture diagram for 8085. So definitely there will be a question directly or indirectly from this diagram, and it's a very huge topic, right? So for the given question paper like the pattern, we will be asked only to write a part of that. So even the diagram is asked to draw the diagram. Maybe only the addressing registers or as the interrupt or else about the flags. So they might ask you the entire architecture, but they'll particularly ask about one of the blocks which you can see here, right? For example, if it is only about registers, you need to write about this one. I think you can see what I'm marking here. And if it is about the flag register, so here we have the flags. There are 5 flags here, and sometimes they ask only about the interrupts. So you need to concentrate more on this block. You should remember the entire diagram, and it is somewhat might be difficult, but it is very easy if you understand how the accumulator is connected. Already we know accumulator is the only register that can do arithmetic and logic operations, and that is why this is connected directly to the ALU. Whereas the other registers are only for storage purposes. These are the registers which are used for the storage purpose, right? So all these are connected by an internal bus, and this is the bus you can see. So likewise, you can see different diagrams. Even if you Google about the 8085 architecture, you'll get a very colorful diagram. The registers will be mentioned in different color. So after this one, after this topic, so you can see in these notes. So the description is given in these notes as well. So you can see this is the entire description about the registers, etc. And one important thing I asked you to note down is the flags, right? So we have the flags here in this topic. So this is the flag register that is shown. So sometimes they'll ask you with an example, just not the flag. Uh, so in microprocessor, you can see the same question can be asked for the 2 marks or 7 marks or 14 marks. You need to understand how much to actually write about. And the thing is, you will be having a lot more diagrams. If at all there are any kind of programming you want, like different programs, I think I can provide the material also for the lab programs which are given earlier. So this is the explanation about everything, and this is what is meant by example. Okay, if you want to explain the registers or as the flag register, you can give just take a small numbers and give example. So it actually depends on how you represent your answer. The diagrams part is okay. You need to explain this answer. So there is an explanation in this notes that is provided, and later we go with this one. This is about interrupts. What are the different types of interrupts, and they are summarized like a table here. Okay, so if you're asked about only the interrupts, you can see about their priorities, about their usage, etc. Okay, then coming to the next one, pin diagram. Most of the students actually, even they ask me about the pin diagram, and you can go with the older versions of the, old question papers. Very rarely they ask you the question paper or as the sorry pin diagram in the question paper. So I just know that you can ignore that. It is less priority. So they explain all the pins here as well. And finally this addressing mode. So in this first chapter, what are the main important topics I already uh, just quoted are architecture diagram, flag register, addressing modes, then finally the instruction set, right? So these are the addressing modes. We have 5 addressing modes. Better you remember instruction example. So in this there are 5 addressing modes, right? For everything there is an example given, like immediate addressing mode, there is ADI, direct addressing mode, indirect addressing mode, etc. So for each of them, just remember one example, one instruction. Okay, there are 240. You don't need to write everything, right? You just write one instruction for everything. Okay, already there are so many questions in the chat box. I guess I think I'll address them. Maybe they are actually looking into the old question papers and the segmentation. Okay, after you completed this topic of 8085, you can see this about instructions. Right? In the next topic, that is, yeah, in this material what you provided, you already have some programming, basic programming of 8085. So in 8086, coming to 8086, so in this notes you can see almost 40 odd pages are given for 8085 itself, because that was the first chapter that is explained very in detail. So the next concepts are just given briefly. So this is a unit 2. So you can see the diagram of 8086 here. And now you just compare this diagram with the previous diagram. So it is actually divided into different units actually. BIU indicates bus interface unit and EU indicates execution unit. Okay. So again here we have the registers. Again we have the ALU here, right? The flags, the control unit, etc. But one thing here is in bus interface unit it is divided into segments. Okay. So the explanation should be about the segments here. If at all the architecture of 8086 is asked, okay, concentrate on the segments because that is what the important topic is. So this one, the next immediately you can see the explanation about segment, and because this memory is also divided into different segments here, and one important concept is pipelining. 8085 doesn't support the pipeline concept, but whereas 8086 supports pipelining. I think you might be covered that in CO. You studied about pipelining, how the execution is done faster when you use the pipelining kind of thing because of the instruction queue there. So, so you just compare this topic with the earlier topic. What you studied, just you have the same thing. The only thing extra you need to study is what is more compared to this, like what are the extra features that 8086 has. So three things to remember. This will work in maximum minimum mode. This will support the pipelining, and this has more addressing modes and flags. Okay, so there is a kind of segmentation also. So you can see the flag register here. There we have only five flags. Here we have more than five. So already we have the different control flags here. I think you can see it on the screen. Interrupt, direction, and trap. Okay. So there are some reserved bits also. You can see that U indicates user different flags. So that is reserved for the future case. So for each of them, again, example is given here. And this is the segmentation shown here. So if at all memory segmentation is asked, you can see this one, how these parts are segmented and out of the available memory. So what is the memory available here? I'll just write it here. So for 8086 we have 20 address lines. 20 address lines indicates almost 2 power 20. That is the size of the memory. This is equal to 2 power 10 is 1 kb, so 2 power 20 is 1 mb, which is 1 megabyte. So that is 1 MB physical memory that is available here. So which is divided as, each of these segments is divided as 64 kbytes. Okay, 64 kilobytes. The other segment is used for the memory. So after the flags and all, again you can see the small instructions. Okay, because there are several addressing modes here, and most of the people have a doubt how many addressing modes are there for 8086. Some people say it is 8, some people say it is more than 8, like some people write with 11. So the thing is, I'll just show you the addressing modes. You give the least priority to the pin configuration. Maybe it might be asked, doesn't mean that it is not there. So you can see the addressing modes here. So almost here there are 13 addressing modes. The thing is here, in few textbooks or else if you notes what you find, like for example you see 10 and 11, they write it like direct and indirect. Okay, direct and indirect, auto increment and auto decrement. So they combine one or two addressing modes. But you see the first five addressing modes are very basic addressing modes. They are also available in the 8085. So the one thing is you are going to add the relative address and also you have some few more addressing modes here. Okay, the first four in this page, what you can see, the first four and the last one: direct, indirect, register, immediate, and implied. These are very basic addressing modes that are present for any kind of device actually. Basically, what is addressing modes means actually how in an instruction we refer to a particular location. Okay, I'm getting the data from particular location. So how you are referring that address of that location? Either you directly say that, or else you immediately send the value, or which is present in another register, or you refer that indirectly. That is what an addressing mode is. And so there are so many questions here. I think in the chat box, which I'm unable to see.
Uh, so shall I
Again, you
present
write the
all the
chat.
comments sir, in the chat box?
Yeah, address calculation actually is given here in this. how they calculate this address. If at all the instructions are given, then you can actually there's small example problem here. So this is the set of instructions what I'm showing on the screen. And here, whenever you have the calculation part, for example, the value from one location should be added to another location, provided they will provide an address. Okay, that is what we actually show in the addressing mode. I'll show you that here. Okay, so here you can see how it is given here. The example is given here. Move dx comma cx plus 0010. So there is a relative address which you add to the original address. For example, if the instruction is, I'll zoom in a bit. For example, the instruction is move. Here it is given right. Cx comma x means the contents from accumulator are stored to the C register. But here you can see this is, for example, there is some relative address which is like 0010. So from this hexadecimal value, the content of this CX is added, and that value that gives you a new memory location. Okay, so that is sent to the DX. So the value from that particular location where we add the value from the C register plus 0010. Okay, so similarly there are some examples given here and based indexed related address in this one also. Okay, we are adding the segments and also the address given here, and we are getting the new address. That is how we calculate the physical memory location. So, I mean, when you go deeper into this one, you need to write the programming part, etc. So, if at all you really had that good enough time to prepare in the last minute, you can go with that addressing, or else go with this addressing modes, flags, and the artext diagram. So, immediately after completing this one, go with the seventh chapter, because you see when you read the two microprocessors. Okay, you see the syllabus is arranged in such a way that 3, 4, 5 are also actually in the same stretch, but the seventh chapter is microcontroller. So if at all you, my suggestion is you can go with the last topic after completing one and two, which is microcontroller, because you'll see the similar topics here. Again, you have the architecture diagram. Again, you have the flags, the addressing modes, instruction set, etc. So it is somewhat easier, but actually I feel easier, and I think most of the students also say that. Okay, so this is the architecture diagram for microcontroller. Only thing first of all you understand is you understand what is a controller first. What is the difference between processor and a controller? This is very frequently asked question, at least for 2 marks. Just let us know what is the difference between processor and a controller, because you are studying all these devices. See, already this is the third kind of device I am mentioning already: 8085, 8086, 8051. And in fourth and fifth chapters, we have the extra peripheral devices. So only one thing you can do is you understand first of all the difference between the processor and the controller. So in simple terms, I will just tell you in simple terms that a controller is a true computer on chip, whereas a processor is asking different questions. Sir, what is the use of the subjects? Of course, you'll see the subjects in the next semester when you do the embedded systems and other program.
Sir, shall I display the comments, sir, on the screen?
Even actually, I'm also watching the
Ah,
uh,
okay.
comments. The comments there.
I can show you. This is from Kavya, sir. Flag registers, addressing modes.
Only the questions related to this subject can be asked here, because there is a lot of concept here, because it's
Hmm.
really very short time. Maybe we have planned earlier. Coming to this exam part, so that is what I'm mentioning here. You just go with these topics. First of all, understand the difference between processor and a controller. Then you'll easily understand the RTX diagram. So you'll simply understand what are the extra things the microcontroller can do. Okay. So in the first slide here, there is a difference between. Okay, there is a difference between processor and a controller. You can see this is a mostly the asked question. Where a microprocessor, you can see ALU, accumulator, working registers, PC, PC is a program counter, stack pointer, clocks, and circuits. And you can see what are the extra things that a microcontroller has here. Now, it has a timers, counters, I/O ports, okay, internal ROM, RAM, okay, interrupt circuits, right? So it has I/O ports, etc. And that is what's shown in the RTX diagram below here. And in this, sometimes mostly, since if at all the architecture diagram is asked for 8085 and 8086, uh, here they'll specifically ask about the special function registers. I think earlier one of the students also asked the question, what are the timers and serial controllers that are available in 8051? And you see the same name also repeats for the fourth and fifth chapter, where we have the peripheral devices. Each of the peripheral device has its own functionality. Like 8255, 8251. One is used for parallel communication, parallel interface. One is for serial interface. One is for keyboard interface. And 8259 is responsible for interrupt controllers. So some of them are already inbuilt available here in the special function registers. You can see the IE, IP. So if at all they are asked, see one thing is I already mentioned there are lot many diagrams and lot many registers to remember. Like for example, these special function registers, each of them has a specific diagram. Okay, each of them has a specific diagram here. So understand the features of this one. The again the flag. This is here the flags are mentioned as the status program status word, or simply called as PSW. So like I mentioned, go with the flags, addressing modes, instruction set in an order. So that is what you can see: addressing modes, instruction set, and very basic programs. When we understood the logic of addition, subtraction, multiplication, division in the first chapter itself, you can use the same logic, just some instructions will just change. Okay, the data transfer and arithmetic instructions will change their format. Other than that, the logic is same. So when you complete 1, 2, and 7, most probably you can easily answer the three essay questions. Okay, for the given paper, right? So that is my suggestion for students. If at all you have any other idea, you can also go with that. But my suggestion is personally you can go with 1, 2, and 7 chapters, and later you go back to third chapter. Right. So the third chapter contains. Because can you share your syllabus screen once?
Yeah, sure, sir. Yes, syllabus is on the screen, sir.
I think I'm delayed. Okay.
So can you
Third
see the
lesson,
syllabus?
since you are so many asking the third lesson problems.
Hmm.
Yeah, this is the syllabus. So in third lesson, you can see about it is given about the semiconductor memories and interfacing concepts, because so many people had the confusion about what about the interfacing concepts. It starts with semiconductor memories. The one thing you remember is you remember the uh, types of semiconductors. If it is all a theory question, because you just shared my document there, the
Yes, sir,
notes.
sure, sir.
You might have having a textbook. This notes actually feels like a huge, huge book of 200 pages, but this is actually consolidated notes. Okay, it really takes so much time to actually read everything, but so you just go with this one categorization of all the semiconductor memories that are available, and the difference between RAM, ROM, SRAM, DRAM, and this is like how the construction of each cell looks like. This is the EEPROM cell, and this is SRAM, which is designed with the flip flops. Okay, so somebody asked mentioned about the problems, right? You can see this is a kind of problem they asked: how to interface. And you see this question, the interface of 16 KB SRAM with 8086. Okay, then you need to actually decide what is the size of the record, because whenever it is given a 16 KB SRAM, so it is divided into two parts, 8 KB and 8 KB. Maybe in this material it is not shown here. So this is also 8 KB. So then you need to decide how many lines are required actually. Okay, so for example, if I'm giving A naught, so what is this line should be? So on. Okay, this is in powers of 2. 8 KB. 8 is already 2 power 3, and K is already 2 power 10. Okay, this is 2 power 10. So total 13. So actually you can give from A1 to 13. So it is A1 to 13, because in this problem they already mentioned that A0 is given to this AND gate here. So as already mentioned, this 8086 has, they already mentioned here, right? I said 8086 has 20 address lines, right? Earlier we discussed it. A0 to A19. So A0 is given here. So this 8 KB, to refer the addresses of 8 KB, we require 13 address lines, so that are given here. So you can also write that same here, A1 to A13, because the total 16 KB we divide in two parts, right? So this decoder is given this A14. So when this decoder is given 0, you understand that this will be 1. Okay, O0 will be 1. And if it is 1, the input decoder, if A14 is 1, this will be enabled. So that is how the table is written in the next page here. Whenever A14 bit, so you can see this from A0 to, they have written up to A19. Okay, and these locations are given from this one A1, right? A1 to A13. This is A13. Okay, so from all zeros to all ones, this is a huge memory location given. And this is odd, because I said A14, if it is 1, we are going to select the odd memory location. And if A14 is given as 0, we are going to select even memory location. That is what mentioned in this table, right? So that is what in the previous diagram is also mentioned. So when A14 is 0, okay, it will select one of the memory location. So that is what the, how you write the table, because this is the final answer you are going to check. If at all they ask you to write the memory location, that is how they write. So in this material, there are some set of problems already given. Okay, set of problems already given here. So you can go with that. And this is another example. Here they also included EEPROM. So again 256 EEPROM and 8 KB SRAM. So 256 is again divided into half, 128 and 128. So you can see here this 256 divided as 128 and 128. Now you can see the calculation part. 256 KB. So you divide into two halves, 128 and 128. 128 is nothing but 2 power 7, and again K is 2 power 10. So it requires total 17 address times. So that's why you can see A1 to A17 for both of them. Okay, and 8 KB RAM is actually divided as 4K and 4K. So which is A1 to, right? 4K means 4 is 2 power 2, right? So okay, so 2 power 12 total, right? And again A note is given here. From this interface they gave this question. So I think I have seen such question in some of the question paper, where definitely for a 7 marks they'll ask you such a problem. So the interest is you write this table, you fill this table from the given things, right? And why did we use the 2 by 4 decoder here? Now the question is, why did we use the 2 by 4 decoder? Because you see we have four memory devices here, right? Two of them are EEPROM and two of them are SRAM. So there are four. So obviously they used 2 by 4 decoder here. And later maybe in another problem they'll ask a very huge one. I think this one. This is another example problem given. You can see here interface and 8 KB SRAM and 64 KB EEPROM, and each of two in number. Okay, he's asking us to make it two different sets of such case, right? So this 8 KB SRAM is divided into 4K and 4K, and the 64 KB is again divided into 32 and 32 here. Okay, so likewise, he's asking to make two different sets, right? This is the first set, and again this is the second set. So total how many memory devices are available here is total 8. 4 in the first set and 4. So that's why we require a 3 by 8 decoder. Of course, in this question, they are already mentioned that is they are given 3 by d quarter. Sometimes, if in the question it is not mentioned, you need to understand that you need to take a 3 by 8. Yeah, for all these questions, actually, the even and odd memory, right? So that's why it will be divided into two parts: even memory location, odd memory location. So is instant interval important? Yeah. See, I mentioned right. Some people are asking about the 8051 architecture. These four questions are common. Okay, you need to just go through that at least because the first chapter, second chapter, and seventh chapter. Okay, the first chapter, second chapter, and seventh chapter. These are the four common topics like architecture diagram, flags, addressing modes, instruction set. For example, in the first chapter, they ask you about the architecture. Right? In the second chapter, they might ask you about the addressing modes, and in the last chapter, they might be asking you program. You can just refer some old question papers. They will give you the idea about this one. And coming to the next two chapters, most of the students are actually ignoring those chapters because they contain a lot more diagrams. Because we know that already after reading all these topics, it is be overloaded actually. But unit 4 and 5, I'll just write it here. How to remember easily. Right? I'll just mention how to easily remember. We study some peripheral devices like 8255 is the first one. Okay, 8251. Okay, I'm not writing them as an alphabetical order or the ascending order. I just write the important topics first. Next, 8253. Okay, 8279 and also 8259. Okay, the last one is 8259. So first of all, remember the name of each device. This is actually programmable peripheral interface. In short, we will write as PPI, parallel peripheral interface. We also call that parallel peripheral interface. This is actually serial bus. Serial bus, we call it as serial bus, and sometimes they also refer it as USART, which is universal synchronous asynchronous receiver and transmitter. So it is responsible for receiving the information or transmitting the information. Okay, and this is about timer. So if at least you remember this one, okay, what I'm writing now, you can easily remember the architectures. For all these devices, we have an architecture, and already you studied, maybe you have studied that 1, 2, and 7 as I mentioned, three different architecture diagrams. And again, you need to remember all this. So this is keyboard interface. I just write keyboard interface, and this is a PIC. PIC indicates programmable interrupt controller. So at least if you remember this one, in the next page we have the architectures like this one. As I mentioned, this is 8255. 8255 is parallel peripheral interface. Okay, parallel IO interface, right? PPI, we call it as parallel programming IO interface. So this actually has three ports. So if you remember this diagram, you can see it might not be so clear, but for all these architectures, you see these are the common thing we have, right? The data bus buffer, read write logic, and a bus internal bus is common. So since this has three ports, port A, B, and C, each of them are 8 bits. So they divide like this: port A, port B, and port C is divided into two parts. That is given in this architecture. Similarly, if you just go with the second second thing, how to remember. I'm just giving a glance of how to remember the diagrams. This one. This is 8251. Okay. What did I mention about 8251 is synchronous, asynchronous receiver and transmitter. So obviously, again, you can see this side we will be having the read write logic data buffer and control. After this internal database, on the right hand side, you can see transmit buffer and transmit control, receive buffer and receive control. So this is what I was mentioning. If at all you might be get confused because there are so many devices, right? One problem is most of the people will be confused. If they ask you 8253, they'll be writing 8255 or 825 and they again write 8259. Okay, so how to easily remember? This is what, if at all you remember this, this has receiver and transmitter. So you can write that architecture. So only one thing is, if at all you're going with these topics, remember the architectures well, and for everything there is a control word or a command word. Okay, there is a control loader command. Go with it. Yeah, already this available in the Etimon website. And there are some questions asked for these topics like programming. So most of the people are also just worrying about this programming or else interfacing 8279 keyboards with 8085. They're like architecture diagrams. Okay, so if at all really have time, because we really had a short time, if at all you can really have the time, there are some block diagrams given in the textbook for this interfacing of the keyboards with 8085, 8086, etc. And for 16 also there is a PDF. I'll just forward to Vikas and he'll upload in the channel. Sixth chapter is about data conversions, ADC and DAC, right? So digital to analog converters and analog to digital converters. So you need to understand when the digital data is given, how this is converted into analog, and if analog is given, how to convert into digital format. We had something around 13 or 20 pages notes. So keep it as a last priority. First complete 1 to 7, then go with 3. And if you really had so much of time good enough, then you go with this fourth and fifth topics. And if at all there is some student who asked me about programming, I'll provide the programs for 8085. The same logic you can use for 8086 as well. And if at all you want to check whether the programs are right or wrong, you can actually use something called as software to check the programs. Right? It might be very late to check the programs, but if at all you want, you can just check that in Sim 8085. That is a software you can just copy paste the program. If I'll send you the program, just copy paste the programs. You'll see how the output is actually. Then actually you can remember the programs. But rather than going with the programs, go with the instruction set first and then the addressing notes. Somebody asked the question, third lesson sums. Yeah, the sums which are mentioned in this material. Because show that material, are you able to show that material?
Sir, I can't get the material.
Yeah, the one you are showing on the screen actually.
Hmm. Unit 4, so that is.
Yeah, that is unit 4. So in this
Yes, sir. Yeah, we can see, sir. Yeah.
okay, in this the third unit that contains the different problems, right? For every model, I gave only one problem. Like first model is for only just the RAM. Next model we included two RAM and ROM with different sizes. There are four example problems. Understand those problems, and if at all the values of the memory are changed, you simply understand how much address lines are given and how the table should be written. Okay, it's very simple if you understand what is everything will be in 2, 4, 6, 8, 32, 64, right? I think this is exactly this one. So you can see I explained only two or three problems here. So this is only SRAM interface. Next they included SRAM and EEPROM also. Then they have the more different sizes. Okay, and finally they had two different sets of. So there are four or five problems given. Understand this one, and if at all they mention you with different size of the memory, like here it is 64 KB EEPROM and 8 KB SRAM. Sometimes they might ask you 16 SRAM and 32 KB EEPROM. Just you need to understand how you divide that and how you write the table. So these are the example questions given, and some examples are shown. So go with 1 to 7 first, then 3, and as long as you have time, you can go to the next chapters also. The materials are actually provided in the website, I guess. Yeah, for sixth chapter also we'll provide it.
Yes, sir. I'll be uploading, sir.
Can you explain how to write a program? Okay, I'll just show one program. Basically, I think it's almost 6:40. We'll conclude within 10 minutes. So I'll just show one program uh, because I'll share my other screen so that
Sure, sir. Sure. I can see the screen.
I think think I stopped it and I'll present
Ah,
now.
fine, bro.
Now I think you can see my entire screen, right?
1 second, sir. I can see the Chrome, sir.
Yeah.
I can see complete.
Just you can type sim 8085. I just want to tell you how to write a program, but I also just want to show you how it executes. Okay. I'll just write a very small program in 8085. This is 8085 thing. So it's very simple. We'll provide the programs. If what all you want to execute, I'll show. See, first of all, I'll tell you how to use this thing, right? You just type sim 8085. This is in the address bar. You can see sim 8085. So here you'll have a small part to write the code. I'll write a very basic program to add two numbers. See, move immediately means you can add. I mean, just to pass a value into register A. I wrote A here, and I write for example 08H. You can see the color change also. MVA is in purple color, which indicates it's a already a known instruction. Okay, and A is in black color, it indicates it's a register, and 08 is the value. Now again I'll write MVI B comma something 06H. It's not B, right? It's okay. So this will what this instruction will do is it will just transfer the value into B. Okay. Now for example, if I want to add these two, the instructions add B. When you read the entire instruction set, you'll understand. So when B is added to accumulator, the result will be also be in the accumulator. I want to store the result in some location. So for example, I can actually see here uh, some memory, right? So I just went to the memory location called 800. Okay, here you can see I just typed 800 here because this program is obviously going to be loaded at 800 in this software. Okay, in this online compiler, it is loaded at. So here you get the original code. In these lines, you'll get the original code. So I'll store my result at this location. Just for understanding purpose, I'll just store this here. So I'll simply write store accumulator. The values in the accumulator. Store accumulator at I'll write 0810. So I'm going to store the result at this one 0810. Okay, this is the 081 and this is the zeroth column. Okay, so that is a simple program called. This is for addition. So for subtraction, you can just change this as subtraction, and we'll also send all the other programs. So since we'll send you the programs in PDF format, you can just copy paste here, just check the result. So you'll understand how it is executed. Very basic programs like addition, subtraction, multiplication, division, largest and smallest. Okay. Now how to run this program? See here we have a button here. You can see when I pass with that cursor there, it is showing that assemble and load the program. It will just load the program, and already it's given here that it is going to be loaded at 800, right? So when I press this one, you can see, yeah, already the code is generated here, right? This is the operation code, opcode. We call it as opcode. For the program, what I have written, the opcode is written here. Maybe you would have done this in the lab. Okay. So now this is going to run the program. So it will run the program entirely in a single step. So just for your understanding purpose, I'm not going to do that. I'll just use this one next button here. You can see run one instruction. So when I click this one, you can see the blue color line over here. So this is indicating that MVA A comma 08H. So if this instruction is run successfully, that 08 will be transferred to accumulator. And here on the right hand side, you can see the registers here, right? So this is the accumulator. So if I run the first instruction, the 0 will be transferred there. You can see I'll just press this key, run instruction here. You can see the value 8 is transferred to accumulator. Now next instruction is move MVA B comma 06. The blue color line is showing. So if I again press this run instruction, that 6 will be transferred to B. So this is the register B and this is the register C. So register D and register E values and so on. Okay. So if I run the instruction again, 6 is transferred here. You can see that. Now for example, add B. Add the instruction will add 6 and 8 and the result is stored again in the accumulator. So 6 plus 8 is again shown here. What is 6 plus 8? It is 14. And you will see the hexadecimal value. Okay, 0E. 0 is the hexadecimal value. You don't see any decimal values here, right? Now this 0 is in the accumulator. I want to see it in the memory here at this location. So simply I wrote store accumulator. So this zero will be transferred to this location for the next one. So you can see the result here, right? So this is how we write the program. We will provide the material for the programs as well. So you can go through that, right? So first thing to write the programs is you need to understand how your instruction sets are working. You need to understand the instructions, at least few instructions, very basic instructions, which we forward you now. Uh, I'll forward the list of programs to Vikas, and I think he'll upload in the Edgemon channel, so you can just get the programs also. But before going to the program, just go with that the basic things I told you: architecture, flags, addressing modes, and instruction set. Okay, so because I'll stop sharing this one.
Yes, it turned up, sir.
Okay, right. So any other problems? I think you can just text back in that. So we'll do the programs.
Already,
Or
I
else you
have
better do
uploaded
one
all
thing.
the material which you
Okay,
have shared me, sir. I uploaded it in app and website also. So if any student just he logs in into anyone, he'll be getting all the materials. Only the sixth chapter we need to upload. That's it.
okay. Six chapter I will send it soon.
Yes, sir. Yes, sir. Yes, sir. So I think that's the session, sir, for today.
This is actually a very delayed session, but mostly I think some more people who don't have this materials, I think you take it from this channel. Maybe for the next subject, we don't drag it too long. I think better we put it earlier in the
Yes, sir. So sorry for like very short notice. I asked you, sir. I know it's my bad. Just like few hours
yeah,
back.
even I am was busy, right?
Yeah. So thank you so much, sir, for sharing your
Then
knowledge with us, sir. Like very,
yeah,
very
maybe for the
helpful.
next subject, you better inform me earlier so that
Sure,
I
sir.
think they
Definitely.
had a gap between each subject, so it's not just
Yes,
the
sir.
day before. You better have this 2 days before
Sure.
that subject.
Yeah, we can have plan it, sir. Like on very short
I
notice.
guess
Yeah.
maybe most of them doesn't ask any doubt from the other subjects. I think except for flat and Nagpur.
Yes, sir. Yeah.
Okay, whatever we'll see that.
Sure. Thank you so much, sir, after agreeing with us. And it's been very good, sir. Like a very good session. Like almost like 80, 90 members have come to the screen, sir. And everyone got cleared with the doubts and everything. So thank you so much, sir, and thank you everyone. So all the materials and everything are uploaded on Eduman website. So if you have any doubts, you can just keep in the comments, or you can end the session. Okay, or else you can just direct message on Eduman Instagram. We can guide you with how to download an app, everything. So yeah, that's it for today. Thank you so much, sir, again for agreeing, sir. We are always very grateful to you. Thank you so much.
Yeah,
Thank you. So bye, guys. All the very best for your exams. Bye bye.